Hello everyone, my name is Mubashir. I am the team lead of Team 20 and my project is called Cluster Stop. It is about a better station discovery for in-city transport through unsupervised learning. So let's have a look through the Kaggle notebook. This notebook is available for everyone to not only go through, but to even run and play around with. So, you first import the usual libraries and foremost and the most important aspect of every data science project is to get the data. So we first started off with trying to come up with our own data, but then it occurred to us that maybe we can salvage something from Kaggle. And before you know it, we found 6 to 7 data sets that were reusable for our purposes. And we narrowed those down to 2 data sets. One is the city of Bournemouth in the UK, and the other is Seattle. So for Bournemouth, the Kaggle dataset included venue locations. So we said, why not take these venue locations and consider them users? And we have their latitude and longitude. And with that, with simple Python libraries, we were able to show their locations on the map. So what's the point of this? The point of this is that for us to be able to simulate the users on a particular or a realistic map, and only then are we able to come up with a way to figure out how to discover better stations. And our approach to this, once we've laid the foundation through the data, is to use partitioning clustering. So the partitional clustering method I've used in this project is called k-means. The k-means algorithm works by having these centroids that find their way through the data and become the central component amongst all the data points. And you have to decide how many clusters exist in this algorithm. So we got the data, we did the pre-processing, and we simply used the algorithm. And using this technique, very roughly, on this small data set, we were able to get an idea of where a bus stop would be the central location amongst our users. So here you can see that the map already includes a few bus stop locations, given this is a real map. And our algorithm was able to, through this clustering technique, come up with a bus stop quite close to this. And this is amazing because 100 data points is very few. The other notable thing, a limitation I would like to be open about, is that given the amount of work we've done, the algorithm places a data point in an area that is not a bus stop at all. You cannot have a bus stop in a park. So you see the algorithm does not know exactly where it places itself. Is that even a correct location? So there is still a need for a human being to look at the result and adjust it accordingly. But nonetheless, the power of this algorithm has been demonstrated. And now let's talk about the clusters. So in this case, I chose 7 clusters. Now we have techniques to help us figure out what would be the right amount of clusters. One such technique is called the elbow method. And the elbow method in this particular diagram is not really visible, but it demonstrates there's this trade-off. There's a point where that particular number is the more feasible cluster, as it reduces the square mean error, as well as it doesn't completely become fixed, because you don't want too many clusters, or they'll become, each person will have their own cluster, and that is incorrect. The other technique is a Silhouette technique. And both of these techniques are complementary, and that will give you some idea of what kind of cluster what kind of number to use as a cluster. With that done, we move on to using a bigger data set. And the second data set we used was Airbnb's Seattle listing of all the apartments, etc. So this time we simulated houses as users. And this time the data set is not 100, but 7,000. So again, we use the technique to figure out what the right cluster will be. We use the k-means algorithm. And now for demonstration purposes, we did not run this for, say, from one cluster to all the way up to 400, because that would be incredibly time consuming. But had we done that, it would have displayed to you, and you would have been able to play with this data and see where that elbow point should have been. And for demonstration purposes and to quickly run, we entered small values and went with the cluster size of 350. And this is our result. It will display soon because the number of points on the map are incredibly, so many. It takes a bit of while to upload. You can notice, and you can zoom in, and you will be able to visually inspect whether the algorithm was capable enough to come up with right bus stops. I hope you have fun exploring this project. And if you have any questions, please let me know. I will be more than happy to explain things to you. And if you would like to further build upon this, I have given a few directions that you can take. Have fun, and thank you.